So here we'll be talking about inconsistent and dependent system. Um, so if we are solving a linear system using a substitution method and elimination method, as we saw in chapter 10, now we can tell when a system is dependent or when it is inconsistent. But when we have to use row operations, when you are applying row operations to a system, how can you tell? Like the questions we solved earlier, the last question, we had a unique solution. But what about if there is no solution? How can you tell from your echelon form? So this answers that question. It says, if you have a linear system in what? In row echelon form, it means after you convert your linear system to row echelon form, you watch out for this. It says, suppose the augmented matrix of a system has been transformed by Gaussian elimination into row echelon form. Then exactly one of the following is true. How do you know? There will be no solution if what? If the row echelon form contains a row that represents the equation 0 is equals to C, where C is not 0. In that case, we say that the system is what? Inconsistent. So let me just show you this figure here. So for example, if after you convert a system, the augmented matrix, to an echelon form, and you arrive at something like this, look at this one. What does it mean? It means that, remember, this is our constant. So this is in echelon form, yeah? So since this is in echelon form, it means we're supposed to do back substitution. But if you look at this row, everything is 0. So it means you just have 0 equals to what? 1. This is not true. 0 cannot be 1. This is false statement. So this means that there is no solution. But if you are in a situation like this looks nice. This one, where are the leading? You see, these are the leading entry. 1, 1, 1, 1. So every variable, each variable is a leading variable. So you see from here, you can take Z to be 8, and you can get also, you can do your back substitution to get Y from here, and you can get X from here. So this shows that there is one solution. But if you are in this situation, look at this situation. Here you have 1, 1. Here you have 0, which is okay. So this is still in an echelon form. But the problem is that the right-hand side is also 0. So it means you have 0 here equals to 0. You see, this is always true. And whenever this happens, we say the system is what? Is dependent. So it means you have infinitely many what? Many solutions. Okay. So let's just answer these questions. Look at this example 7. Example 7 says, find the value of K so that what? This system is going to be unique. That will make this system have a what? A unique solution. So this is like an augmented system already. So let's say this is this one. Now, for it to have, so all you need to do is we will try to convert to what? We will try to convert to, let's say we try to convert to what? To echelon form, right? We'll try to convert to echelon form. And how can you do that? How can we convert to echelon form? We can convert to echelon form by doing the following, because now this is 1 already here. This is what? This is 3, but it's okay. It's okay to be 3, or you can convert it to what? We can convert it to 1. So let's first of all try to convert this to echelon form. This is 1, so this has to go to 1. So we can do what? We can simply do 1 over 3 R2. So this will be 1, 3 minus k squared. And this is 0. This is 1. This is what's minus 3. You know, remember we're dividing by 3. So this is just going to be what's minus k squared minus what? 2 over 3. And this will become k squared minus 1. And here will be 0, 0, and here will be k squared plus 5k minus 6. And this is going to be this one. Okay? So I think this is the best we can get. This is 1 here, and this is also 1 here. So the next is that this is supposed to be 1. So you can divide this by itself if we want, but there is really no need for that. So if you want a unique solution means that what? This guy here, if you want to have a unique solution, you want this, for you to have a unique solution, everything has to be what? It has to be a leading. So you want here to be 1, right? Yeah, you can want this list to be 1, or it should not be what? It should not be 0. That is what we want. So if you want one solution, a unique solution, let's say you have a unique solution. So the most important is that you want this guy here to be what? To be 1. And here also should not be what? Here can be anything, right? So what you can just say, we want k squared plus what? 5k minus 6. This should not be equals to what? 0. Because if this is equals to 0, then you have a problem. If this is equals to 0, this will be 0, and this is not equals to 0. So, but if this is not 0, let's assume that here it's what? Is 2. Let's say it is 2. And here is what? 0. Then you can see that you are saying that 2x, no, 2z now in this case. So you can say that 2z is equals to what? 0. So which means z will be 0, right? Which is good. But so for you to have a unique solution, the variable this cannot be what? It should not be 0. It can be any number, because if it is any number, you can divide by a non-zero constant to make it 1. So what this simply means is that you're going to have k plus what? Plus 6. You can factorize this easily. And this is not equals to what? This. So it means that k cannot be minus 6, and also k cannot be what? 1. So look now. If you take k, so k can be any number except what? Except this one. So you will have, this is our solution. Now, if you let k, for example, let's assume k is 1. Let's just assume k is 1. You see, if you take k to be 1, what will be this? This will be 1 plus 5 minus 6. So it means this side is going to be 0. And what will be this? Remember, k is 1. Here is also going to be what? Here is going to be 0. So it means you're going to have 0 and 0. But if you have 0 and 0, it means it's always true. So it means you are going to have what? Many solutions. So that is why you say we don't want this place to become 0. We don't care about this side. But this side can be any number, but this is this. So the main thing is that this number here should not be what? Should not be 0. So, and this is true for any value of k in this interval. Now, let's deal with the independent infinitely many 0. For you, okay, so let me just put something here. So you can have 0, 0, but the last entry should not be 0. And here can be anything, the third one. So for infinitely many solution, which will be dependent system, you want everything to be what? 0, 0, 0, right? You want the last row to be This is what we call dependent system. So it means you want this one to be 0, and you also want this to be 0. So we want k squared plus 5k minus 6 to be 0. And at the same time, we also want what? Minus k squared plus 1 to be what? 0. So if you solve this one, this means you have equals to 0. And here, it means that what? K squared is equals to 1. And this means k is equals to minus 6. K is equals to 1. And here means k is what? Plus minus 1. So you have to take the intersection because you want these two conditions to hold. You want here to be 0, and you want here also to be 0, right? So it means here you have minus 6, 1, and this and you intersect it with what? Minus 1 and plus 1. If you take the intersection, the only thing that is common is 1. So this is only 1. So k has to be 1. Then no solution. When do we have no solution? No solution can happen if the what? Your last row is 0, 0, 0, and let's say the right-hand side is not 0. Because if this is 0, 0, so for example, if this is 0 and this side is not 0, then it means it's false. So it means your k squared plus 5k minus 6, it has to be 0. And the right-hand side, which is minus k squared plus 1, should not be what? Should not be 0. So this we already talked about it. This is the same thing as k plus 6. We already factorized this before. And this means that k is not what? Plus minus this. So it means k is equals to minus 6. And what? K is equals to 1. And here, k is not equals to plus minus 1. So here also, all you need to do is you look at this k. This is k is minus 6, k is equals to 1. But k cannot be plus or minus 1. So it means k cannot be 1. So it means your k just has to be what? Minus 6. Because these two conditions need to be satisfied. This one is saying minus 6 and 1. And this one is saying any k except what? 1 and minus 1. So it means the only k that is possible is minus 6. All right, so we will take more examples in the old exam. Thank you for, when we go to the old exam, we will take more questions, yes. Thank you for watching.